Good afternoon, everyone. It's me again, Hector Nkosi. I'll be taking you for Mathematics Grade 10. So guys, today we'll be looking at Analytical Geometry. Yesterday we looked at November paper 2, 2018. So today we'll be looking at November 2017 paper 2. So we'll be looking at question 3, the analytical geometry. Hello everyone. Hello Mbali. Hello Glenn. Hello Zelnel. Hello Nelly. Welcome guys. Kamugelo, I can see you also. Okay, that's perfect, boys and girls. Tracy, hello. Okay, cool. That's perfect. All right. Okay. So now, guys, remember as usual, just need to remember as usual, guys, if you've got any queries or if you've got any questions, you can always email me at nkosihector28@gmail.com. Please, guys, only email me for maths queries, right? Not the technical queries, because I've been receiving other technical queries of how to log in. I have no idea actually, but here you must email me based on grade 10 mathematics, right? So as I said earlier on, today we'll be looking at the analytical geometry, right? I know yesterday it was a bit tense, but today we'll be looking at a different question, and I'm sure by the end of today's lesson, everything will make sense. Okay, Mpumelelo, I can note you are raising your hand. All right, okay. Let's hear what Mpumelelo is saying. Okay. Yes, Mpumelelo. Hello, Mpumelelo. Mpumelelo. Hello, Mpumelelo.
Yes.
Yes. What's your question?
I wasn't here yesterday.
Okay. Yeah. Also, you were not
Yes.
here yesterday. Yeah.
Yeah.
Okay. Okay.
Like updates.
Yeah. Okay. No problem. What we are trying to do today, basically, in Mpumelelo, it's just it's the very same chapter that we were doing yesterday, but we're doing at the, we're looking at the different question, right?
Oh, okay.
Yeah. Okay. Cool. Cheers.
Sure.
Okay, guys. So now for today, guys, I just need to stop sharing the PowerPoint slide and go straight to the question so that we can start with today's lesson. Okay. So now, guys, yesterday we looked at this question. It was a triangle. Remember, guys, with analytical geometry, you'll be asked how to calculate a gradient. You'll be asked how to calculate the length, of which you use the distance formula. You'll be asked to calculate certain coordinates of a certain point, of which you can use your midpoint formula or your distance formula, guys, or you can even use your gradient formula to calculate those, right? You can be asked to calculate the area of the shape. You can be asked to calculate the angle. So all these things, guys, you just need to know, and no one knows which one they'll ask in an exam, right? So in an exam, guys, you need to be comfortable with all the shapes, right? What do I mean by all the shapes? Can you see in 2018, they've asked them a triangle, right? You need to understand what is the triangle, and you've covered your triangle from grade 7. You need to know the basic of the shapes, how to calculate their perimeters, how to calculate their areas, like for triangle, for instance, how many types of triangles do we have? We know we've got skeleton, we've got an isosceles, we've got a right angle triangle, and you also need to know their purposes. Today in 2017, they've asked them a rectangular, right? A quadrilateral, right, guys? So also you need to know what is the area of a quadrilateral, guys, right? And now, if we look at this question, this was question 3 and it was taken from November 2017, paper 2. And yeah, it was given, it says in the diagram below, P7 is to 4, Q6 is to 6, R0 is to 3, and S, point S, T is to K. Can you see they did not give you the coordinates of S? And bear in mind, guys, that a coordinate, it's given by X and Y. What's on the left, it's always X. What's on the right, it's always Y. So even here, 7 and 4. 7 is X, 4 is represented by Y. Point Q, 6 is given by X, another 6 is given by Y, right? Point R, point 0 is given by X, point 3 is given by 1. Same applies as S. T is given by X, K is given by Y, right? Are the vertices of a quadrilateral. Remember, guys, when we talk about vertices, we talk about corners in a simple English, right? Of PQRS. So this is our shape, a rectangular. It's given by PQRS, and these are the coordinates. So now let's see what the first question requires from us. The first question, it says to you, calculate the length of PQ, leave your answer in set form. Now, guys, by now you need to be able how to calculate a length. Every time when the question says calculate the length, you must think of a distance formula. So you need to know your formulas. Remember, some of you were asking yesterday, but say, how are we going to memorize our formulas? Guys, you do not have to cram your formulas, but in order for you to understand your formulas, you need to do lots and lots of questions. You can't just do one question and expect to know your formulas, right? So you must always do lots and lots of questions. That's where you can memorize your formulas. That's where you'll be familiar with your formulas. And that's where you'll also be familiar with the language that is being tested, because when they speak about length, in your mind, it's just 2 marks. So in your mind, it just needs to work so fast and say, oh, length, which means it's a distance formula. Oh, if they say I must leave my answer in a set form, which means now I must leave my answer in a square root. Does it make sense, boys and girls? So now all these things, guys, like we're killing 2 birds with 1 stone. As much as you're doing your questions, you must also learn the exam techniques, guys. Does it make sense? Perfect. Now, let's see now from our memo or our solution. Remember this, guys, is your distance formula. They won't tell you unless the examiner is very lenient that, okay, calculate the distance from P to Q, right? The examiner, unless he or she is lenient. But most of the time, they'll just say calculate the length of PQ, or what is the length of PQ. So you must know from the back of your mind that the length, we always use a distance formula. And the distance formula, it's always given by x2 minus x1 all squared plus y2 minus y1 all squared with a square root. Right. So basically, you must take the coordinates of P and coordinates of Q and insert them in this formula. How do we insert them in this formula? By saying, okay, we see that what's the first letter that is starting is P. The second letter that is starting is Q. So your X2 will be the same as your XQ. Your x1 will be the same as your xp all squared plus your y2 will be the same as your yq, and your y1 will be the same as your yp all squared. Then you substitute all the values here from the coordinates. Then you simplify 7 minus 6, it's 1 squared. 4 minus 6, it's negative 2 squared. And we know that 1 squared plus negative 2 squared, it's 5. Therefore, the answer is square root of 5. Meaning now, when they say leave your answer in a set form, meaning do not simplify the square root of 5. I know the square root of 5, it's a decimal number if you were to simplify it further. But please, please, guys, stick to what the examiner is asking. Guys, I'm telling you right now, test and exams are very simple only if you stick to the instructions, because the examiner here is emphasizing that your answer, leave your answer in a set form, meaning now leave your answer in a square root format, right? But if, let's say, it said calculate the length of PQ, then they just kept quiet. Well, you can leave your answer in a decimal, right? But the examiner, if said to you, leave your answer in a set form, leave it in a set form. Just follow the instructions. You'll never go wrong. Does it make sense, boys and girls? Now, we know now that PQ, the length of PQ or the distance of PQ, it's actually the square root of 5. Does it make sense, boys and girls? Okay, I just need to check at the comments. All right. Okay, it seems like everyone is still okay. Okay, that's perfect, boys and girls. Great. Then now, if you look at 3.2, 3.2, it says if T, meaning coordinate T, is the midpoint of QS. Where is QS? This is QS. So QS, right? So if it's a midpoint, we assume that the midpoint is the point that is in the middle. T, it's somewhere here, and its coordinates, it's given. Determine the coordinates of S. Now, guys, you need to work backwards. You are given the coordinates, you are given the answer of the midpoint. So now, remember, in order for you to calculate the midpoint, you need 2 points. However, the other point, you don't have its coordinate, right? Or its coordinates, right? So now you need to work from backwards using your midpoint formula. So basically here, they've tried to highlight to you that actually use the midpoint formula to work backwards in order to calculate the coordinates of S, right? So guys, remember, your formulas are in your textbooks. Your formulas, some of them, they're in your study guides and stuff. Okay, I see a question here. Okay, cool. Oh, you just following. Okay, I thought it was a question. That's perfect. Right. That's perfect. Now let's look at 3.2 now. If you look at 3.2, 3.2, remember now, this, guys, is the formula of the midpoint. Remember the formula of the midpoint? It says x2 plus x1 over 2 is 2, y2 plus y1 over 2. It must give you the midpoint answer. However, in this case, the midpoint answer, it was given. So basically, you are supposed to work backwards to get the point of S, the coordinates of S, right? So basically, what you're going to do, remember, this is given by X and this is given by Y. So you're going to equate what is for X and equate what is for Y. So in this case, your X and Y of a midpoint were the same, 7 over 2, 7 over 2, right? But not always they'll be the same, right? So here it's just that your midpoint, it was X and Y midpoint was the same. Then now you're going to say, okay, 6 plus X over 2 is equals to 7 over 2. This 7 over 2 of X. So you pair here, you group all the X's with their answers all the y's with their answers. Does it make sense? Then here, 6 plus y over 2, 7 is equals to 7 over 2. Can you see now, guys, why we were doing equations earlier this week? Because now this is helping you. You're solving for x here you're solving for y. Can you see how important it is, guys? Then what do we do here? We need to cross multiply, right? When we cross multiply, we're going to say, okay, 7 times 2, it's 14, right? Then here it's going to be 2x, 2 times 6 plus x, it's actually 2x plus 12. Then you transpose and you get your x. You should know this by now, guys, on how to solve for x. Remember, we did equations, I think 3 times or 4 times, if I'm not mistaken. We started from last week, Friday, and we finished the equations up until Tuesday, actually, if I'm not, no, actually today it's Wednesday. So we started our, not Friday, it was a holiday. So we started on Thursday, on not on Thursday, but last week Wednesday. We finished on Tuesday because yesterday we started with our analytical geometry. But what I'm trying to say, you need to know your equations, guys. You need to know how to solve for x. No wonder, guys, I was going slowly with you on how to simplify, because I know, guys, algebra in maths is the core fundamental thing that you need to know. Without algebra, guys, you won't be able to calculate anything in maths. So everything of factorization, simplification, how to solve a how to solve x in an exponential equation, how to solve for x in a quadrilateral equation or in a trinomial or in a binomial. So guys, you just need to be familiar and be comfortable with your algebra before you can start all the chapters in maths. So make sure that you are comfortable with that. So now we got that the coordinates of s is 1 is to 1 because our x is 1 and also our y is 1. Perfect. Let's look at the next question. Now, if you look at the next question now, it says to you 3.3. If the coordinates of s are 1 is to 1, if, right? Basically, this is what you calculated in 3.2, 1 is to 1, the coordinates of s. Show that PR is equals to QS. So show that PR is equals to QS. Can you see? These are what? Diagonal lines. Can you see? These are your diagonal lines. So PR, it's P to R is equals to Q to S. So you need to know, guys, that, and here they were very lenient because in sometimes if they want to be tricky, they can say, show that PR is equals to QS. Can you see now, here the examiner was lenient, was trying to tell you that if the coordinates of S, even if you got them wrong in 3.2 or you did not know how to calculate them in 3.2, but let's assume that the coordinates of S are 1 is to 1, show that PR is equals to QS. So basically they don't want you to lose this extra 2 marks. So even if here, let's say you were not able to calculate the coordinates of S or your answer was wrong, but the examiner is telling you that use what I'm telling you in 3.3 to calculate, to show that PR is equals to QS. So now, if you want to see whether something is equals to another one, what do we need to do, guys? Yes, what do we need to do, guys? Who can tell me? To show whether sides or lines are equal. Okay, I'm sure majority of you are still thinking, but because of time, let me just show you fast. Okay, cool. So basically this was 2 marks. And I mean, there are so many ways of doing this, right, guys? So basically, you just need to calculate the distance formula of PR and calculate the distance formula of QS. Then, if your distance formulas are the same, therefore, you've got the answer. Does it make sense, guys? Because now your PR is 7.07 and your QS is 7.07. Therefore, PR is equals to QS. Basically, it's just to calculate the distance for the one side and calculate the distance for the other side. That's how you can get whether those two are equal, right? As they told you. Therefore, you know how to calculate your distance formula by now. I do not have to repeat this again because you know how to substitute everything. Please, please, guys, practice makes perfect. The more you practice is the more you're going to ace your mathematics, guys. Without practice, unfortunately, you're not going to cope. So you just need to do lots and lots of questions, guys. Do the questions from your textbook, do the questions from past papers, do questions from the study guide, do questions from wherever resources that you have. And one thing I want to advise you guys with, um, that thing has worked for so many learners, and this is what I also encourage my learners at my school, right? Is to always, guys, always, when you do a past paper or when you do a question, try to do the question as per a chapter. Don't do one question from question 1 up until question 10. So, for example, if this week or let's say for the next 3 days, you are looking at analytical geometry, go to the study guides or go to the past papers where there are analytical geometry and do those specific questions on analytical geometry so that you can see how they ask questions. But you can't say, okay, you want to practice something and you sit down, you do analytical geometry. After 1 hour, you do exponents. After 2 hours, you do number patterns. In that way, guys, you're not going to learn. But it's good to do everything in one chapter. What do I mean? I mean, like you must study as per chapter. Does it make sense? Perfect. Now, let's look at paper, 3.4. It says to you, show that QR, where is QR? QR is perpendicular to RS, right? What does it mean? Yesterday they asked the very same question, but they asked it in a triangle. Remember, they are saying to you, show that QR is perpendicular to RS. Perpendicular, which means the lines are meeting at a 90 degrees. Does it make sense, guys? Which means this and that meets at a 90 degrees. Remember yesterday they asked the very same question, and now I want to take you and show you the very same question. If you look at the at yesterday's questions, how they asked it yesterday, they said to you, where is it? Oh, actually, it was the statement. It was the statement. They said to you, um, um, Q and R are vertices of a triangle such that PQ is equals to QR and PQ and PQ is perpendicular to QR, meaning PQ is perpendicular to QR. So here, even if they did not tell you that this was perpendicular, you could have seen because of this small square. The small square means that this is a 90 degree, right? So now in this one, we're not given the small square. So can you see the importance of doing lots and lots of papers, guys? So here, meaning now, here, um, because it's PR, where is PR? Yes. No, QR. So QR and QS. So which means here there's a small square also. Can you see, guys? The more you do the questions is the more you're going to be familiar with your work. Okay, cool. So now let's show whether these are perpendicular to one another. We've got all the sides, or we've got all the coordinates of these three vertices. And remember, guys, when we talk about perpendicular, we need to think of a gradient, guys, right? So now let's look. So there are so many solutions here. So basically, you can calculate the gradient of QR, and we got that. Remember, the gradient, it's always x over, changing y over changing x, right? Does it make sense? And remember, when you multiply the two gradients of the sides, they must give you -1. That's where you will see whether those two sides are perpendicular or not. If you multiply 1/2 times -2, it does not give you -1. Therefore, QR and RS is not perpendicular to one another. But because it gives you -1, when you say half times -2, you get -1. Therefore, QR is perpendicular to RS. So basically, you were proving the perpendicular lines. Now, this was for 4 marks. So you were getting a mark for calculating a gradient of QR and getting a mark for calculating a gradient of RS, right? So it was 1 mark, so it's 2 marks so far. Then you were getting a mark for multiplying the both gradients. And you were getting a mark also for getting a -1. So let's say now you've messed up your answer here. Maybe instead of putting -2, you've just inserted 2. And you said half times 2. Can you see? You were just going to get +1. But for the fact that you multiplied, you took your gradient as it is here, you multiplied by 8 here, you were always going to get a carried forward mark. But your answer here was going to be wrong because you did not arrive at -1. And you have proved that QR is actually perpendicular to RS. That's perfect. Then now, 3.5. It says to you, hence, now they love this word in mathematics, guys. You'll see it in grade 10, you'll see it in grade 11, you'll see it in grade 12, right? In your metric, right? So, hence, meaning that the answer that you have used or the answer that you got in 3.4, hence, take it as it is and use it in 3.5. So, hence, what type of spatial quadrilateral is PQRS? Motivate your answer. Now, guys, here you need to know the types of your quadrilateral, right? You need to know all the what you call what do they do. Remember, for triangle, I explained yesterday to you that okay, we've got different types of triangle. You need to know that okay, a right angle triangle does this, right? Let's say an isosceles triangle do this. This type of triangle does that. So each and you must go study all your shapes, guys. All your shapes, you must study them in order for you to ace your analytical geometry. You need to study your shapes. Basically, analytical geometry, you are basically uh, analyzing your shapes, all your different shapes. And guys, remember, you did shapes in grade 7, you did shapes in grade 8, you did shapes in grade 9. And I know, guys, you did them in detail, right? So you need to know that, okay, when you talk about any um, quadrilateral, you know that you're talking about a shape that has 4 sides, number one. Now, you need to know what shapes have 4 sides. And what are their what you call things that are similar or things are not similar and stuff like that. So already, guys, you should know by now that this is a rectangle, right? This is a rectangle because we know that in a rectangle, two sides, opposite sides are equals to one another, and um, the vertices must meet at a 90 degrees. All these things you have learned in grade 8, guys, in grade 9. Can you see now? It comes in hand now or handy to you. So now, if we look at the solution, it says to you is a rectangle. You get a mark. The diagonals are equal, and one of the interior, it's one of the reason, or you can say angles equals to 90 degrees. Does it make sense, guys? Or what you can do, you can actually prove the sides, right? You can actually prove the sides, right? So remember now, the diagonals, they must be equal. So here you had three things to do. It's either you are going to prove via a 90 degrees angle, or you are going to prove by saying this is equals to that and this is equals to that, or you are going to prove about the diagonal sides, whether this is equals to that. And that, yes, the diagonal ones, they've already asked you guys, they've already asked the diagonals. Remember, guys, they've already asked the diagonals, so it's easier to use what they've already asked you so that you don't waste time in an exam. Does it make sense? And that was for 2 marks. Now it says to you, calculate the size of angle S. So the RSQ. So that's the size of the angle S. So now, if you look, RSQ, so this is your RSQ. So it's RSQ. Can you see? They want this angle basically. What is the size of S? Because where there's a small cap, the small cap is within, on top of S. So meaning they are looking for angle S, right? And they just want this. And this, I can say it's given by a triangle because now RSQ, it's more of a triangle. Remember, in a rectangular, you can get two triangles because if you put your line here diagonally, you can get one triangle and another triangle. So basically, they want you to calculate the angle for S. Now, how okay, how many marks? It's 3 marks. So there are so many ways of which you can do this one also, guys. Right? So basically, you can use whatever that you are comfortable with, guys, right? However, because we haven't started with trigonometry, I don't like the course, right? Because this one now means that you need to be comfortable with your trick. But remember, they've also asked us the very same question yesterday. If I can go back to yesterday's question, the very same question it was asked. And this was, where is it? Just hang on. This was the area. Oh, this was the size of theta with reasons. So basically, it's the same thing, right? But now, remember yesterday when I showed you guys, okay, I see a chat here. I see a chat. Yes, yes, Miss P, we are still continuing with analytical geometry. Yes. Yes, Faith, you are right. Some of you haven't done trigonometry yet. Yes, you are right, Faith. That's why I haven't started to do trig yet, because that's part of terms to work, right? So analytical geometry and your number patterns and your algebra, it's part of term 1. Kamogelo says, I know nothing on this topic because we didn't do it yet. Okay, it's fine, but try to follow by all means. But it's part of term one. Um, sometimes at the schools we mix the chapters and stuff. So I was just moving according to the what you call the what you call the annual teaching plan basically. But I know other teachers, they prefer to start with a certain chapter before the other chapters, and I do understand. I'm a teacher also, so sometimes I also do that with my learners, where I don't follow what is written on black and white, but I do what's going to benefit my kids more. But then at the end of the day, you guys are going to answer, to answer the very same paper. Does it make sense, guys? Perfect. Okay, cool. But what I was trying to say, guys, this one actually, I don't want to do it because you haven't done trick yet. And it's easier when you have done trick. This one of calculating the size of the angles, I don't want to do it yet because I know you guys haven't done your trigonometry yet, right? If you majority of, because I know trigonometry is part of term two. So I know none of you haven't done your trigonometry yet. So let's pack this one for now, but it's going to make sense. I'm going to come to all these questions that they include trick um um once we have done trick with you guys, right? So tomorrow again we'll be looking at the analytical geometry, guys. Please, 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 um you need to be comfortable with your analytical geometry. So tomorrow, then Friday, if tomorrow majority of you are fine with analytical geometry, on Friday we need to do number patterns, right? Then once we are done with algebra, equations, analytical geometry and number patterns, therefore that's where we can start with the terms tools work. That's where we can start with our trigonometry. That's where we can start with our Euclidean geometry, right? Okay, I can see Stella. She's asking, say, was this whole week about analytical geometry? No, actually, we started the analytical geometry yesterday, Stella. So you're not that behind, but tomorrow we will be looking at another question of analytical geometry. Then Miss P says, say, some of us have started it, but our online classes. So yeah, okay, Miss P, she's agreeing with me that they've already started at their school. Okay, Kamogelo. Okay, cool. That's perfect, guys. So don't forget, guys, let me stop sharing so that you can see my email address. Um, those who wants to ask certain questions, feel free to ask the questions, guys. I like to display my email address at the end of the lesson. Thank you so much, guys, for always taking this time and taking your studies very serious. Yeah. So this is my email address. So you can always email me at nkosihector28@gmail.com. This is our end of our lesson. Miss P, the lesson lasts for 40 minutes. So 45 minutes or 10 minutes, 50 minutes, it's when it's the 5 minutes grace period. In a normal circumstances, the lesson only lasts for 40 minutes, right? But because the question that we're doing today, it allowed us to do 40 minutes. I don't want to start anything new in this extra 5 minutes. Yeah, but unless you guys had questions, no wonder I went to the chat, the group chat, so that I can see whether you guys had any questions or not. But yeah, that's from me, guys. Thank you so much, Faith. Or Faith is saying, thank you, sir, for ending early. Some of us appreciate it. Okay, Faith, no, that's not going to happen anytime soon. We're still going to do more difficult stuff. Okay, bye Nelly, bye Anke, Swat, bye Stella. I appreciate you too, Miss P. Bye guys. Khahlo. Okay, guys, I'll see you tomorrow, same time. Tino, goodbye also. Okay, cool.